Hi everyone. In this lesson we're going to work with congruent triangles and the properties of congruent triangles, and we're going to use them in order to find the lengths of sides and the measures of angles. So in our last unit of transformations, we learned what congruent figures are, and congruent figures are figures that is one obtained from the other through a rigid motion or through a sequence of rigid motion. So that means if figures are congruent, then those two figures have to be exactly equal to each other in all aspects, in the lengths of segments and the measures of angles. And that's what I have over here. Two triangles are congruent if their corresponding sides and corresponding angles are congruent. So they had to have all the parts congruent. Corresponding angles here would mean what we used to call A and A prime, B and B prime, and so on. The only difference here is that we're not going to be calling A prime anymore. We're going to call any other name, and you have to be able to identify which one is corresponding to which one. So if we look at the diagram here, we could say that triangle JKL is a reflection from triangle ABC. It is indeed a reflection. It would have to be a reflection on the line that's passing through the middle of them, sort of like that, not very exact, but just an example. So if we consider that being the line of reflection, then A and J would be corresponding. So we're not calling A prime anymore. So J is corresponding to A, L would correspond to C, and K will correspond to B. So, and that's what I have over here. Angle A corresponds to angle J. Those are the corresponding parts, and therefore they had to be congruent. Angle B is congruent to angle K, and angle C is congruent to angle L, because those are the properties of rigid motions. The corresponding, or I would say the measures of angles and the lengths of segments are congruent in rigid motions, and that's why we say here they are congruent. So if we now look at the corresponding sides, in this case, let's say side JL, which is between the angle that is marked with one arc and three arcs. So that side should be corresponding to the other side that is between the one arc and the three arc angle. So JL corresponds to AC, which I have here. CA corresponds to JL. KL, which is between the two arcs and the three arcs, should be corresponding to the other one between the two arcs and the three arcs. So KL corresponds to BC, and therefore they are equal. So I have here BC congruent to KL, and the other part, which is AB and JK. So those are the corresponding parts which are congruent, because those are the properties of rigid motions. And one important thing is that whenever we have congruent triangles or congruent figures, any type of congruent figure, the names are written based on the correspondence, which means that if I have here ABC, triangle ABC, the first letter on the other one should be what corresponds to A, and that's why we have J over here, because J corresponds to A. The second letter here is B, and on the other one it has to be the one that corresponds to B, which is K. So K and B are corresponding, and then C and L are corresponding. So if you don't have the diagram marked as what we have here, which will help us to identify the corresponding parts, you can identify from the way it is named, because we will know immediately that A corresponds to J, B corresponds to K, and C corresponds to L. So if we talk about the sides now, the side that is named with the first two letters, AB, would be corresponding to the side that is formed by the first two letters on the other part, JK. So AB corresponds to JK, which is what we have here. AB congruent to JK, and so on. So by the way that is named here, you will know what parts are corresponding and therefore congruent. With that, we're going to do our examples. And here we have example number 1, which says, if triangle ABC is congruent to triangle DFE, find the value of x, the measure of angle F, and the measure of angle A. So we're already given that these two triangles are congruent, and we have to find these three things, which are x, the value of x, the measure of angle F, and the measure of angle A. So because we have here the triangles named congruent, we know that A and D are corresponding, B and F are corresponding, C and E are corresponding. Sorry. So I'm going to mark those here. A and C and D, sorry, angle A and angle D are corresponding. That comes from the first two letters. And then B and F are corresponding. I'm going to mark with three angles this, three arcs, sorry. And then C and E are corresponding, and these I'm going to mark with one arc each one. So here we have marked the corresponding angles, which is very important because we're going to be finding the measures of angles here. And now we have the measure of angle B, but we don't have the measure of angle F. So we cannot write an equation with this one, for example. But if we notice at C, no, that will be, yes, C, which corresponds to E. Both of them are congruent because they are corresponding. We have measures for both of them, so we could actually write an equation because we know that corresponding parts are congruent. We could write an equation with angle C and angle E. So that is what we're going to do here. So angle C is congruent to angle E, and therefore we will have this equation, 6x minus 27 is equal to 4x plus 7, because that is what congruent angles are. They are angles that have equal measures, and so we have the equation, and then we solve this equation. So that would be 2x is equal to 7 plus 27. That will be equal to 34. And x would be equal to 17. So we have our first answer that we were requested, which is the value of x. So the value of x is 17. And now we need to find the measure of angle F. And we do not have a measurement over here, but we know that it's equal to angle B. So the measure of angle F should be exactly the same as the measure of angle B. So we can also do that here. So it's angle F it's congruent to angle B because they are corresponding, and corresponding parts are congruent in congruent figures. So the measure of angle F would be the same as the measure of angle B, which is 3 times the value of x, and the value of x is 17 here. So the measure of angle F would be, I think is 51. So it's 51 degrees. So we have our second answer, which is the measure of angle F. And finally, we're going to find the measure of angle A, doing the same method that we just did with measure of angle F and B. So we know that angle A is congruent to angle D because they are corresponding. So we can use the measurement of angle D to find the measure of angle A. So the measure, okay, let me just state first that because they are congruent, we can do this. So angle A is congruent to angle D, and because they are congruent, we can find the measure of angle A by using the measure of angle D. So the measure of angle A would be 2 times the value of x, which is 17 plus 20. And 17 times 2 is 34. Plus 20 is 54 degrees. So we have our third answer, which is the measure of angle A. And so we're finished with this problem, and the only thing that we have done is use the corresponding parts of congruent triangles in order to find what we are being asked for. And now we're going to do a very similar problem in number 2. The only difference is that here we're dealing with the measures of the sides and not the measures of the angles. So given triangle TUB is congruent to triangle TWB, find the value of x and the measure of segment TW. Remember that when we have only 2 letters like this, it means the length of segment TW. So we're trying to find the value of x and the length of segment TW. So we have 2 things to find here, which are those: value of x and length of segment TW. So now these 2 triangles are congruent. That's giving us here. And so by the way that the triangles are named up here, we would know, for example, that the segment TU would be congruent to the segment TW. So TU congruent to TW. Now the segment that is named by the 2 last letters, UB, would be congruent to the segment WB. So UB congruent to WB. And the third one, which is TB, is actually shared by the 2 triangles, and this is the case when we use the reflexive property, because TB is used for both, so it's the same side for both. That will be by the reflexive property, is congruent in both. And we show that in the diagram by marking it with an X. That's how we show the reflexive property in a diagram. So we have the 3 congruent sides marked in the 2 triangles. And now we see which equation can we write. If we look at these 2 sides, we don't have the measurement of TW, which we know is equal to TU, but we don't have it, so we cannot write an equation. But in the other one, we do have the measurements for both, so we can write an equation with that. So because UV is congruent to segment WB, notice that when I name the segments, it's also named based on the correspondence. If the first one is U, then the first one here should be what's corresponding to U. And the second one is B, and B is repeated in both, so it's B on the second spot for both. So because segment UB is congruent to segment WB, we can write the equation 3x plus 15 it's equal to 75, because that is what congruent means. It means that they have equal lengths. And so we can solve this equation. That will be 3x is equal to 60. 75 minus 15, that will be 60. And so x would be equal to 20. And so we have our first answer, the value of x. And then we want to find the length of segment TW. And TW is this one here. We don't have the measurement or the representation of the measurement, but we know it's equal to TU, so we can use the measurement of TU. So TW it's congruent to TU. Therefore, TW would be equal to 2 times the value of x, which in this case is 20, minus 3. So TW would be 40 minus 3, which is equal to 37. And this would be units. We don't know what the units are, whether centimeters or meters or inches, but this is not degrees because this is not an angle, this is a segment. So the length of TW is 37 units. So that's how we use the properties of congruent figures, in this case specifically congruent triangles, to find the lengths of segments and the measures of angles, which use the corresponding parts in order to find the lengths of segments and measures of angles. So that's it for today's lesson. Page number 3 from exercises 3, I think, to 8 is your homework. You don't have to do 1 and 2, 3 to 8. So that's it for the lesson of today.